Okay, what we're going to talk about today are some examples that are going to be very important for some FRQs on the AP test. And that is FRQs where you will be taking a derivative implicitly, and then you will have to have a question, answer some questions about where there might be horizontal tangents, vertical tangents, and this is just a comment about be careful when no tangent line exists. So horizontal tangents are going to occur when the derivative, especially if you have a quotient derivative, is 0 over non-zero. I prefer to do this when I am writing it down than saying not equal to 0. I'm not a fan of that notation. And the same thing here, you get a vertical tangent when you have a division by 0 where you have non-zero on the top. And then here, be careful, this is a case, this 0 over 0, that indeterminate form is you have to throw those points out at the end. So you always have to check and make sure that both the top and the bottom are not 0, because then those would be thrown out. All right, so we're going to take a look at the first example. Now, in this first example, we already know the answer to this, and I am going to make a slight change to this. I would prefer, I'll tell about the reason why in a second, but I'm going to change that to be 100. So that when we're looking at this, we know the answer because this is nothing more than a circle centered at the origin with a radius of 10. So we know that the coordinates of each of these points are fairly simple. Like this is 10, 0, this is 0, 10, negative 10, 0, and 0, negative 10. And we already know the locations of the horizontal tangent lines. That would be at 0, 10 and 0, negative 10. And we know the vertical tangent lines are going to be at 10, 0 and negative 10, 0. So I already know the answer before I start this. I'm just using this example to kind of show you what's going to happen when we use implicit for this. We're going to do part A is going to be the horizontal, part B is going to be the vertical, and then the last one, when it's the slope 3/4, that's going to be part C. All right. Now, the first step in all of these problems, and that's kind of true for A, B, and C, would be whenever you want to talk about the slope, we are going to take the derivative implicitly. You do want to make sure that you show that you are taking the derivative and with respect to what variable. And so I usually just go d dx and then do x squared plus y squared equals 100. So that way I can go ahead and just show, hey, I'm taking the derivative with respect to x. And then we do it. And remember that when you're doing this, you are following it with the chain rule. If it helps you, you can always do 2x dx over dx, which is really just 1, plus 2y dy over dx equals 0. So we take the derivative implicitly, and then we typically solve for dy dx. So dy dx, and I'll leave it to you to verify, subtract 2x divided by 2y would be negative x over y. So this portion you kind of do at the beginning just to get your derivative so that you can answer these questions. All right, so now we'll come over here and we'll do A. Now for A, you want to write this sentence because this is how you get possibly at least a point on the AP. Horizontal tangent when, and then you say what's going to happen. So dy dx, which is equal to negative x over y, is going to be horizontal when the top is 0 and the bottom is non-zero. So on an AP, there are many times where that actually is enough to get you at least 1 point. Now, looking at this, and this is one of the things that I want you to really think about, that what you're actually doing here is it's kind of like a system of equations. In order for this to equal 0 over non-zero, the top x would have to be 0, the bottom y cannot equal 0, and then of course the other equation that you know about this graph is that x squared plus y squared equals 100. So really, every single time that we are doing one of these problems, what you are doing is a system of equations. Now this, of course, is a really easy system because to solve it, all you're going to do is plug your 0 in for x and solve for y. So y squared equals 100, y equals plus or minus 10. Now, in a lot of these problems, because they are implicit, they do ask for the coordinates. And so you do want to make sure you answer the question that they ask. So I am going to go, the x was 0 and the y was 10 and 0, negative 10. And those would be the coordinates where you have a horizontal tangent. Right? Now for B, same kind of idea. It's fairly straightforward. You would say vertical tangent when your dy dx, which is negative x over y, equals, in this case, non-zero over 0. So we make that statement. So this is going to be the system where now y is 0, x does not equal 0, and we have our original equation, x squared plus y squared equals 100. So again, we solve by substitution, plug the y in, and very similar, x squared equals 100, x equals plus or minus 10, so 10, 0, and negative 10, 0. Now, even though I'm not saying that, I am making sure that I am checking that the y values that I get satisfy this statement and that x doesn't equal 0 here. Because if it did, you would have to throw those out as not being an answer. All right, so now what we're going to do this next one, and this is why I changed this example to be 10 or 100 in the equation. All right, so this one we're going to know when the slope is equal to, what was it, 3/4? When is the slope equal to 3/4? Okay, slope equals 3/4 when our dy dx, which is negative x over y, equals 3/4. Now, the reason why I did this is I want you to be very careful. This does not mean that x is negative 3 and y is 4. You are solving a system. This is an equation where if I were to cross multiply, I'm really looking at that negative 4x equals 3y, or y equals negative 4/3 x. That's the relationship that I'm getting out of this. You don't say that the top equals the top and the bottom equals bottom for a fraction, because this could be 6/8, or it could be 12/16. We don't know what this was before you simplified it, so you can't just say x is 3 on this. You're doing a system, and that's your y. And then the other thing that you have is your x squared plus y squared equals 100. And then so you're going to solve that one. Let's do substitution. So we would have x squared plus negative 4/3 x squared equals 100. Let's see, x squared plus 16/9 x squared equals 100. Combine these together, 9/9, common denominator, 25x squared over 9 equals 100. Just come up here. Multiply by 9, divide by 25, x squared would equal 36. X equals plus or minus 6. And then now you do have to do a little bit more work in this case, because I do want to get the coordinates. When x is 6, what are the y values? Now, a comment about that, yes, I could plug into this equation, but I'm going to try to remind you to keep it simple. Use the easier formula. You have two options. So I'll put a star by it up here. You want to use that formula, because then if you basically plug in 6, you're going to end up with -8, and then plug in -6, and you're going to get +8. So use the easier one when you are plugging it in. All right, let's take a look at the second example. So now on this one, this is going to be a little bit more kind of in tune with what we're going to do. And that is, I have no idea what this looks like. So, but it's the same process. The first thing you're going to do is you're going to show your work for taking the derivative with respect to x. Now, the interesting thing about this one is you want to be careful, because it's checking your derivative rules, that you are following the chain rule, and then in this case, there's going to be a product rule and a chain rule there. So that equals 3. So my derivative, I'm going to go ahead and just do it next to it, would be 4x plus. Now that derivative of xy is a product, so it would be x times the derivative of y plus y times the derivative of x. And then we have plus our 8y, using our chain rule, dy dx, equals 0. So we get it to there. Now I am going to go ahead and solve this for dy dx, and you'll get used to this. We do so many of these in practice. You have a dy dx in both of these places. So there's one here and there's one here. So we do want to keep those together, and then everything else ship it to the other side. So you're going to have the x from here plus the 8y from here times that dy dx equals, and then everything that didn't have it, ship it to the other side, minus 4x minus y. And then you're just going to divide. So we're going to end up with dy dx equals, now I don't like it when it has this negative that's over there. So when you're looking at that, I typically like to go ahead and factor that out. Let me just double check my derivative here. So this would be 2x squared. Derivative of that would be 4x. And then your chain rule, so x dy dx plus y plus the 8y from there equals 0. All right, so I'm going to pull the negative out, 4x plus y. So now when we take a look at this, let me move myself up here now. So this part of it is kind of your standard beginning, which would probably be like a part A on your free response. So now we would do horizontal, tangent, when, and then we would go ahead and do our system, and we would say what we're looking for. So that would be when dy dx equal negative 4x plus y over x plus 8y equals 0 over non-zero. So we say what we're doing, and then we're going to go ahead and do it. And we say, what's our system that we're going to be doing here? Our system that we're going to be solving is going to be 4x plus y equal to 0. X plus 8y does not equal 0. And then our original equation, we'll bring that down, 2x squared plus xy plus 4y squared equals 3. So that's the system that we're going to solve. So I would do a substitution. So y equals negative 4x, and we will plug that in. All right, so our system becomes, when we plug it in, 2x squared plus x times negative 4x plus 4 times negative 4x squared equals 3. Just do a little algebra. You would have 2 of the x squareds minus 4, so that would be negative 2, and then plus 16 times 4. All right, so 2x squared minus 4x squared. 16 times 2 is 32 times 4 is 64, so plus 64x squared equals 3. Combined like terms gives me what? 58x squared equals 3. So x equals plus or minus the square root of 3 over 58. And you don't really need to simplify that. You can just come in and say, okay, what are my coordinates? 3 over square root of 3 over 58. And then our negative square root of 3 over 58. And then plug back in. And again, remember, plug back into the easier one. I will remind you about that. We're going to use this one to plug back in. So it's just going to be minus 4 times 3 over 58. And then 3 over 58. And then we're done with that part. Okay, now what I would like you to do is to go ahead and try part B on your own. And I'm going to pause the video and then check your answers at the end. Okay, coming back, so we set our vertical tangent when the derivative, which was this fraction, is non-zero over 0. Set up your system, solve, and then those are your answers. Now again, just stressing before this video ends, make sure you check that you have verified that this works, that this x plus 8 times that y does not equal 0, and that here we need to check that this one works for this one, that 4 times the